Welcome. So what I'd like to do is show you how to identify all the zeros if we're given two zeros of 2i and negative 2i. Now, just like if we were given any real zeros, we're going to, basically the zeros are going to represent the same thing. They represent our values that are going to make our function equal to 0. So we can say x is equal to 2i and x is equal to negative 2i. However, by understanding the fundamental theorem of algebra, we know that there's going to be four total zeros. So we have two complex. We either have two more complex, or we're going to have two real zeros. So what we're going to need to do is we need to figure out all the rest of the zeros. Now, however, if we know we have a zero, though, we can find the remaining zeros by using synthetic division. And I also have another way that I'm going to go through as well. But to get some practice with our synthetic division, especially with operations of complex numbers, I can take one of my zeros and then use synthetic division to find another factor. So in this case, remember synthetic division, we're going to take the coefficients of all of our terms, make sure if we're missing any term that we include a 0. But in this case, I have 1, 1, negative 2, 4, and negative 24. All right, so now what we're basically going to do is bring down the 1. When I bring down the 1, 1 times 2i is 2i. Now, I can't add a 1 plus 2i because 2i represents an imaginary unit or a complex number. So I'm just going to leave that as 1 plus 2i. Now I have to multiply 1 plus 2i times 2i. So all of my work I'm just going to do over here just to make sure I do everything correctly. So by applying distributive property, I have 2i. And then 2 times 2 is 4. I times I is I squared. I squared is negative 1. So that gives me a negative 4. So therefore, that gives me a 2i minus 4. Well, I can only add the real components here. So negative 2 plus negative 4 is going to give me a negative 6. So I have 2i minus 6. Now I multiply 2i minus 6 times 2i. So I have 2i times 2i minus 6. Again, you're going to want to apply distributive property. So in this case, I now have a negative 4, and then that's going to be a negative 12i. So negative 4 minus 12i. Well, 4 plus negative 4 is just going to be 0, so I'm just left with a 12i. Negative 12i times 2i is going to give me a negative 24i squared. I squared is negative 1. Negative 1 times negative 24 is going to give me a positive 24, and that's 0. So technically, I have this factor here, which I could write as coefficients. My remainder is 0. That's my constant. That's my coefficient of my linear term. That's the coefficient of my quadratic term. And that's the coefficient of my cubic term. However, writing a polynomial with imaginary or complex coefficients is really not going to be too beneficial. So we want to make sure we know that since we have a complex number as 1, 0, we know that the conjugate is going to provide another 0. So I'm going to further divide this by using synthetic division. And all I'm simply going to do is now take my coefficients of my quotient, the factor that was of my quotient, to further divide this. So therefore, I have 1, 1 plus 2i, 2i minus 6, and negative 12i. OK, so now we're just going to do synthetic division. Bring down the 1. 1 times negative 2i is going to be a negative 2i. 1 plus 2i plus negative 2i is just going to give me a 1. 1 times negative 2i is a negative 2i. 2i minus 6 plus a negative 2i. Those divide out, so I'm left with a negative 6. Negative 6 times a negative 2i is going to be a positive 12i. And therefore, you can see, again, we have a remainder. So I've factored it further. Now I'm going to write this one because now my coefficients are of real numbers. So therefore, now I have x squared plus x minus 6 as my other factor, right? So now I want to see, well, can I further divide this? Because I know that this times my other two zeros, x plus 2i and x minus 2i, right? Those are my other two linear factors because those are also zeros. So remember, if you're going to use like the zero product property, we would set these all equal to 0. Can I solve for x squared plus x minus 6? Well, absolutely. I can actually use factoring to solve this, which is going to be very helpful. So I could have x plus 3 times x minus 2 equals 0. So therefore, x equals negative 3, and x equals positive 2. So therefore, my zeros in this problem are going to be negative 3, positive 2, and then 2i and negative 2i, which were already given to us. Okay? Now, however, there is another way to do this. If synthetic division and operations of complex numbers is not something that you're very strong with, what we can also do is, remember, here's your two factors, right? These are your zeros. And if we had our zeros, we could rewrite them as factors. Now, I could also multiply those two factors to give me another factor. And the way I always explain this to my students, if I know 2 and 3 are both factors of 24, and if I multiply 2 times 3, that gives me 6. Well, 6 is also a factor of 24. So if I multiply these out, since these are a difference of two squares, I'm going to end up with x squared minus 4i squared. Remember, I squared is negative 1. Negative 1 times negative 4 is going to be a positive 4. So in reality, another factor in this polynomial is x squared plus 4. And what I could always do, rather than using synthetic division, if I take my two complex zeros, multiply them, or write them as factors, multiply them, I get a factor, but it's a factor without having any unreal coefficient or having any imaginary coefficients. So if I already have a factor and I have a polynomial, to find further factors, I could use long division. So that's what I'm going to do in this case. Here's all this extra work I did. I'm basically going to take x squared plus 4, and I'm going to divide it using long division into my polynomial. And again, you're going to obtain the same answers. I'm just doing two different ways to do the same problem. So you can kind of decide which one's going to work best for you. So x squared goes into x to the 4th, x squared times x squared is x squared. X squared times 4 is a positive 4x. Subtract the rows. Here I get 0. Here I get negative 3. Oops, I'm sorry. That's not going to go there. That's going to be 4x squared, so I have to leave that over here. Here, I'm just going to have 0x cubed, because I'm going to use that as a placeholder. Well, x cubed minus 0x cubed is really just 0, so that goes to x cubed. Negative 2x minus 4x is going to give me a negative 6x squared. Now, x squared divides into x cubed. That's going to be a positive x times. X times x squared is x cubed. X times 4 is going to be a positive 4x. Subtract again both rows. That goes to 0. Negative 6x minus negative 4 is a negative 10. Oops, I did that again. That becomes a positive 4x. That's over there. Positive 4x, that's a 0x squared. Negative 6x squared minus x squared is just going to be a negative 6x squared. Here, I can't subtract the 4x from anywhere, so I'll bring down this 4x. Bring down the 4x, that's a positive. 4x minus 4x is going to be a 0x, or just 0. So now I do x squared divides, x squared goes into negative 6x squared, negative 6 times. Negative 6 times x squared is going to be a negative 6x squared. Negative 6 times 4 is going to be a negative 24. Bring down this 24. Then again, I subtract my rows. This gives you 0, and that gives you 0. Therefore, my other factor, when I take my factor that I got from my real zeros, I multiply them to give me a factor. I divide that into there to get my other factor, which is actually the quotient. Then, as I already showed you, I could factor that down. So your zeros, again, are going to be negative 3, positive 2, 2i, and negative 2i. There you go, ladies and gentlemen. That is how you find those zeros when given, or find the remaining zeros when given two imaginary zeros. Thanks.